Hello everyone. In this video, we will cover pure endowment. Consider an n-year pure endowment of 1 issued to an individual at age X. For pure endowment, the insurer pays 1 at time n if the individual survives to that point. That is, an individual at age X survives to age X plus n. Let Z be the present value random variable for this insurance. We have a 1 payable at this time point. The present value is due to the power n. The probability kx greater than or equals n, that is npx, and we have the PMF of z. Z is 0 if kx is less than or equals n minus 1, that is corresponding to the event that the individual dies before reaching age x plus n, or else z equals due to the power n if kx is greater than or equals n. This is the survival benefit. The expected value of z is nu n times the probability of reaching age x plus n, which is npx. And the expected value of z squared, the second moment, is due to the power 2n times npx. The actuarial notation, we have the big A notation, x angle n, and then the 1 is above the n. This indicates that the payment is made only the individual survived by the end of the n-year period. A more convenient notation, we denote this as NEX. E stands for endowment. All right, so the expected value of z, nu n times npx, the notation is NEX. And then the second moment, the notation is, we have the pre-superscript 2 because comparing this two expressions, this expression is simply similar to the previous one, except that we are evaluating a double force of interest. So we have the pre-superscript 2 NEX. We can express this as nu n times npx, and then nu n times npx is NEX. Therefore, the expected value of z squared is nu n times NEX. The variance of z, we get this expression. Simply by definition, the expected value of z squared minus the square of the expected value of z. Let's take a look at an example. A 10-year pure endowment of 1 on an individual at age X. Z is the present value random variable at the issue of the benefit payment. Variance of z equals 0.15 times the expected value of z. You are also given that 10px equals 0.7. Calculate the annual effective interest rate. Okay, so we have the time diagram. This is a pure endowment. If the individual can survive beyond age X plus 10, a survival benefit of 1 is payable at this time point. The corresponding present value is due to the power 10. The corresponding probability is 10px. We are given that 10px is 0.7. The actuarial notation, the expected value of z is 10ex, which equals nu to the power 10 times 10px. And the variance of z, we have this expression. The second moment is nu to the power 20 10px, and then minus 10ex, the square of nu to the power 10 times 10px. Upon simplification, we get this expression. And the variance of z equals 0.15 times the expected value of z. Substitute the expression here. 10px is 0.7, and 1 minus this is 0.3. Doing the simplification, we have some cancellation, and then we simplify the expression. We have 0.3 over 1 plus I raised to the power 10 equals 0.15. Nu to the power 10 on both sides cancel. So on the left-hand side, nu 20 only left with nu to the power 10, which is 1 over 1 plus I raised to the power 10 here. And we can solve for the value of I. The annual effective interest rate, 0.071773. All right, then we move on to the concept, the actuarial present value factor. NEX equals nu to the power n, NPX. This refers to the actuarial present value factor. And here, this present value incorporates the interest as well as survivorship. In financial mathematics, nu to the power n is the present value factor, only consider the interest only. More elaboration. Suppose we have a cohort of individual at age x, say this cohort Lx, and then at time n, this cohort of individual reach age x plus n, and some of them dies before reaching this age. So the remaining number of individuals is L x plus n. At time n, suppose we want to accumulate $1 for each of the Lx plus n survivors. That is, at time n, we need to accumulate Lx plus n dollars. At time 0, for $1, the present value is nu to the power n. And for Lx plus n dollars, the present value is nu n times Lx plus n. Amount need to deposit is nu n times Lx plus n. This amount is to be shared to all the individuals at time 0, that is at age x, share among Lx number of individuals. So for each individual, the present value of the deposit is nu n times Lx plus n divided by Lx. Lx plus n over Lx is NPX. So this is the POA endowment, the n-year POA endowment, NEX. We also have the actuarial accumulation factor, which is 1 over NEX. This accumulation incorporates the interest as well as survivorship. Similar elaboration. Two cohort at time 0, Lx individual at age x, and then n years later, the number of individual, the expected value of the number of individual reaching age x plus n is Lx plus n. At time 0, each of the Lx individuals invest $1. And the total amount is Lx dollars at time 0. This number of dollars is to be invested until time n, to be shared among all the survivors at time n. The expected number of individuals is Lx plus n. At time n, $1 is accumulated to 1 plus I raised to the power n dollars. And the total amount accumulated is Lx times 1 plus I raised to the power n. Share among the Lx plus n survivors, that is the expected number of individuals reaching age x plus n. That is Lx times 1 plus I raised to the power n number of dollars divided by Lx plus n. we have 1 over nu n times NPX. This is 1 over NEX. And this is the actuarial accumulation factor. That's it for today's video. Thank you for watching. In the next video, we will cover endowment insurance. See you in the next video.